Hi guys, I will be solving question 12.33 from Young and Friedman's University Physics textbook. A cubical block of wood 10 centimeters on a side floats at the interface between oil and water with its lower surface 1.5 centimeters below the interface. The density of oil is 790 kilograms per meter cubed. A, what is the gauge pressure at the upper face of the block? Okay, so the pressure at any point depends on the weight of the fluid above it. So if we're talking about the upper face of the block, okay, we care about the weight of the oil above it. So part A, pressure at the upper face equals the pressure from the oil. And the pressure from the oil is equal to rho oil, so that's the density of oil, times gravity, times the height of oil above the surface we're interested in. So we're interested in the upper surface, which means we're interested in this height right here. So let's see, rho oil, okay, the question tells us that the density of oil is 790 kilograms per meter cubed. Okay, we know what gravity is, 9.8 meters per second squared. Okay, we now need to figure out what this height is. Well, the question tells us that the lower surface is 1.5 centimeters beneath the top of the oil. So this height right here would be 0.015 meters. Now let's just calculate this quickly. Okay. So the pressure at the upper face is 116 pascals. Okay. Part B, what is the gauge pressure at the lower face of the block? Okay. So what I said before still holds here. Okay, the pressure at any point depends on the weight of the fluid above it. So if we're looking at the lower face, we have two different types of fluid above the lower face. We have this much water above it and this much oil above it. So we need to consider the pressure from the oil above it and the pressure from the water above it. So P oil plus P water. Now P oil is going to be rho oil times G times H. The pressure from water is going to be rho water G H. Okay. Now we just got to figure out what to plug in. Okay, so P oil, question says, what is that? Yeah, 790 kilograms per meter cubed. We know what gravity is. Okay, so for this height, okay, so these are the two special heights we care about. Let's start off with the oil. Okay, so the question tells us that this distance here is 10 centimeters, okay, which is just 0.1 meters. Okay, now let's move on to water. Rho water is 1,000 kilograms per meter cubed. Okay, that's just a known fact. Water has that density. G, okay, same old 9.8, whatever. Okay, H, so for water, okay, there's only this much water above our surface of interest. So we only care about this height, okay? So this height is going to be 0.015 meters, okay? And the reason for that is if this height is 0.015 meters, it means that this one also has to be that amount, okay? So 0.015 meters. Okay, I'm going to calculate this and come back with the answer. So for your answer, you should get 921 pascals. So now it is time for part C. What are the mass and density of the block? Step 1, we're going to draw a free body diagram. Okay, so acting downwards is going to be the force of gravity or the weight of the block, and upwards is buoyancy. Now we have buoyancy from two different fluids. We have buoyancy from water, and we have the buoyancy from the oil. Now because this piece of wood is just floating, it's at rest, we can say that the total buoyancy equals the weight of the block. Okay, so the system's at rest. Now the total buoyancy is the buoyancy from the oil plus the buoyancy from the water, which equals the mass of the block times G. Now we can further not change up this equation. Replace it with variables. So that will be, for the buoyancy of oil, that is equal to rho oil times G times the volume of oil displaced. For the buoyancy of water, that's equal to rho water times G times the volume of water displaced, and that equals the mass of the block times G. Let's get rid of G to simplify our equation. So that becomes rho oil V oil plus rho water V water equals the mass of the block. Okay, so before I proceed, I just want to clarify what I meant when I said the volume of oil or the volume of water displaced. Okay, so this goes to Archimedes' principle. The upward buoyant force on a body submerged is equal to the weight of the volume of fluid that the body displaces. I'm going to draw a cube, or I'm going to replicate the cube in the diagram just to better demonstrate this. So this is a cube, so its width is 0.1 meters, its height is 0.1 meters, and its length is 0.1 meters. Now, if we're talking about the volume of oil displaced, that is going to be equal to the volume of the cube that's submerged in oil. Okay, so that's going to be equal to the top part, the volume of the top part of the cube. Now, if we are talking about the volume of water displaced, that's going to equal the volume of the cube that is displacing water. Okay? So this chunk right here. Now we know that this chunk of the cube, okay, we know that this has a height of 0.015 meters. Which means that the remaining top of the cube is going to have a height of 0.1 minus 0.015. Okay, now that height is going to be 0.085 meters. So if I want to find the volume of oil, that's going to be equal to the length, which is 0.1 meters, the width, which is 0.1 meters, and the height would be 0.085 meters. And if I want to find the volume of water, that will equal the length, which is 0.1 meters, the width, 0.1 meters, and the height, which is 0.015 meters. Now, if I calculate all of these numbers, let's see. Water is 0.00015 meters cubed, and the volume of oil displaced is 0.00085 meters cubed. So now I'm going to plug in all of these numbers. Okay, so raw oil we established is 790 kilograms per meter cubed. Volume of oil displaced is 0.00085 meters cubed, plus raw water, 1,000 kilograms per meter cubed, times the volume of water displaced, which is 0.0015 meters cubed, and all of that equals the mass of the block. Okay, so I'm going to calculate that. Okay, so you should get that the mass of the block is 0.82 kilograms. Okay, so we just solved the first part of part C. The second part of part C asks us to find the density. And this is a very simple task because we know density equals mass over volume. We know the mass of our block is 0.82 kilograms. And because our block is a perfect cube, its volume is going to be equal to length times width times height, which is 0.1 meters cubed. And if I quickly calculate that, so 0.82 divided by 0.1 cubed, you should get that the density of the block is 820 kilograms per meter cubed. Thank you for watching.